So here's one for you. Now you can pause the video and read this question if you want. I'll give you the gist of it. 39% of seniors are skipping the last day of school, which is becoming a problem for the school district. Now, some businesses have decided to offer some incentives, some prizes for students that show up for like a senior fest day on the last day of school to get everybody to show up. And they want to know if this program is working. So what should we do to test this thing? Well, this is going to be a one sample proportion test, and we need to get the null hypothesis and the alternative hypothesis. Okay, this is a kind of a janky question, but I'm going to do it anyway. So here we go. Now our null hypothesis is going to be that no matter what people do, this 39% of the seniors are going to be gone on that last day. But if we do this thing for the seniors, less of those seniors are going to be absent. That's the alternative hypothesis. So they do it for the school year, 1 year, and of the 398 seniors, 129 were absent, which is lower. It is 32% versus 39%. Is that enough for us to justify that this program is working? Well, we don't have an alpha level on this thing. Now, if you do a problem like this and there's no alpha level stated, we're going to just assume that the significance level is at 0.05. Okay, there's some other problems. I'm not exactly sure if this is really a random sample. And also, could we say that there are a total of 4,000 seniors? So we could say actually over the entire district, there might be 4,000 seniors in the whole school district if they're going to try to do this district-wide. So those are random, normal, and independent. Okay, so the normal seems to be okay because we're going to take 0.39 and multiply it by, 398, and then 1 minus 0.39, so that is what, 0.61 times 398. Those are both bigger than 10. So random, normal, independent. Let's just say, for argument's sake, that we're good on that. And let's continue this problem. Okay, what do we do next? So we are going to do a one proportion z-test on this thing. Now that should be stated in the plan part of state plan do conclude, along with normal, random, independent. Okay, let's do the do part. Now we've got some numbers here. We need to do the standard deviation. So the new standard deviation of the proportion, so p hat, because we have the proportion of the population, we say 0.39 times 0.61 divided by the sample size, which was 398. So that gives us, let me see, 0.0244. Now we're going to do our test statistic, very much like the z-score. The test statistic, which is, what was it? It is our p hat, right, which is 0.32 minus what we got, which is 0.39, which is what we usually get, and then divide that by the standard deviation. And what do we get for that? And that number is negative 2.86. Pretty far down there. So let's see what our p-value is. Remember, we want to say, is this low enough that we would see a sample like this less than 5% of the time? And that's what we're looking at. Oh, I don't know if I mentioned this. I'll mention it again though. If they don't state a alpha level, you use an alpha level of 0.05. Okay, if it's not mentioned. So I put this in the normal CDF. Remember, the lower bound is I always put at negative 1,000, and we want to see from negative 1,000 up to, what was it, negative 2.86. Negative 2.86, And what do we get when we do that for normal CDF? So normal CDF gives us a value of 0.0021. So really, we only have like 2 out of 1,000 chances that this would actually happen, sheerly by chance, if the proportion is still at 39%. So we can reject the null hypothesis in favor of the alternative hypothesis, and our conclusion is, yes, those incentives are working to get our kids to come to school on the last day. Okay, there you go.